So before going to data science applications using machine learning and deep learning techniques, first let me check what is happening in the worldwide, where the data is going, how the data is coming, and how do we store the data, how many servers are required. Please check this URL. Now see this URL www.internetlivestats.com. How many internet users are connected right now? Total number of websites opened, email sent today, and tweets, Google searches today. How many videos viewed right now in this second? See the number. Now the number is increasing rapidly. You cannot read this a huge number. That means every second thousands of users, lakhs of users are connected to this internet. So where this huge volume of data is stored, how many servers are required, how many data centers are required. So this is a very big question. In order to solve this question, we use cloud computing concept in the behind. Cloud is nothing but internet-based technology. The backbone of cloud computing is virtualization and data center. I think everybody knows data center. Collection of high integrated servers at one place is called a data center. Virtualization is the ability to perform multiple tasks in a single system. With the help of popular virtualization technologies are VMware, Hypervisor, Zen, Virtual Iron. So with this, we are creating n number of virtual machines. So that's why Gmail is a best consumer of cloud computing. 24/7, we are getting the service. How many servers are required to store this data? See tweets, websites open, Skype calls, tablets sold, smartphones sold, computer sold. This is the statistics we can see in this present scenario. So today I would like to explain the contents, introduction to data science, statistics components, artificial intelligence concepts, data mining concepts, machine learning concepts, and deep learning concepts. Then we will see the practicals on COVID-19 virus prediction and detection, and COVID-19 strain virus prediction and detection, Ebola virus prediction detection, prostate, breast, and lung cancer prediction detection. These are the applications recently I have executed. 6 database, health database applications I have executed. So the prerequisition of data science starts with data. Data is raw material, fact or image. Data can be anything: audio, video, text, graphics, animation. Processed data is called information. Collection of interrelated data is called database. To manage the database, we are using relational databases such as SQL, MySQL, Teradata, DB2, MS Access. These are the relational databases. Nowadays, we are using relational less databases such as Mongo database, Hive, HBase, Cassandra, etc. Combination of data plus DBMS is called database system. Storing of subset of data warehousing is called data mart. Collection of data marts is called data warehouse. Data warehouse is also called as online analytical processing. Once we are storing huge volume of data, we are extracting meaningful interested patterns from the huge volume of data. That is called data mining. With help of classification, clustering, association rule mining, outlier detection, recommender engine, etc. Then comes to the big data analytics. It deals with the 3 V's majorly, like Facebook database, traffic database, weather forecasting database, health databases, etc. There are problems like volume, velocity, variety, veracity, viscosity, value, validity, etc. So in order to solve big data sets, we are using Hadoop, Spark, MATLAB, Python, advanced Java concepts, etc. Then finally, data science. Data science is the process of examining and extracting hidden patterns, insights from the large volume of data with the help of scientific methods, processes, algorithms, and computer programs. That is called data science. So can anyone give the answer for this logo? Can anyone? Technical name of this logo? Everything we have incorporated in this one. Analysis, process, system, structures, knowledge, programming, everything incorporated in this image. What is the technical name of this logo? The technical name of this logo is called Data Science Word Cloud. Everything incorporated in this one. Then how do we measure the computer information? Computer understands only ones and zeros. 1 bit is equal to 0 or 1. 4 bits is equal to 1 nibble. 8 bits is equal to 1 byte. 4 bytes is equal to 1 word. 4 words is equal to 1024 word. Then kilobytes, megabytes, gigabytes, terabytes, petabytes, hexabytes, octabytes, zettabytes, yottabytes. Hi, I am Robo. My speed is 1 terabyte. My memory is 1 zettabyte. Before that Robo movie, we don't know the terminology of how do we measure the computer information. After that movie, we got to know zettabyte, yottabytes. So thanks to Shankar, director, and thanks to Rajnikant. After that, I have searched yesterday night. There are 2 more terminology is presented now. 1024 yottabytes is equal 1 brontobyte. 1024 brontobyte is equal to 1 geobyte. So it is not GIO geo. That geo ruined students' life. They are not studying these days. They are playing games because of internet facility. So if you ask me, 1024 geobyte is equal to infinity. If you compare normal range, big data range, kilobyte is equal to 10 power 3 and gigabyte is 10 power 9. Terabyte is 10 power 12. Then big data range, if you see, 10 power 15 is called 1 petabyte. 10 power 18 hexabyte. 10 power 21 zettabyte. 10 power 24 yottabyte. So 10 power 27 1 brontobyte. 10 power 30 1 geobyte. That is a maximum measurement of mathematics range. So data is central to data science. Without data, there is no database application. So wherever data is presented, we are going to solve very complex applications in data science with help of machine learning, AI techniques, and deep learning techniques. So data is categorized into two types: categorical data, numerical data. Categorical data, examples: marital status, political parties, eye color. These are the categories of data. Numerical data, again we are classifying into two types: discrete, continuous data. Discrete data is nothing but, say, number of children, defects per hour, like counted items. Continuous data, see, as a human being, we are growing every day. Weight, voltage, measured in characteristics. Then how do we collect the data? There are data collection tools such as interviews, through observation, surveys, usage data, focus groups. We are collecting the data like online forums, in-depth interviews, online communities, web survey chart, etc. So where this data is coming? What are the big databases, big data sources? Like a Facebook database, legacy documents, old databases, media database, cloud database, web database, Facebook database, social influencers, active generated data, data warehousing applications, network related IoT databases. So ERP data is a big database for data science applications. Maybe a transaction data, public data, social media data, data in health, data in marketing, and mobile devices, cameras data, microphones data. Data is everywhere and it can help organizations, any industry in many different ways. Data has become too complex, too dynamic to be able to process the data, store the data, analyze the data, to manage the data with the traditional data tools. Those are SQL, MySQL, Teradata, DB2, MS Access, etc. We are unable to process traditional databases. That's why we are going to unstructured data. To handle unstructured data, we are using Hadoop, Spark, MATLAB, etc. So the beautiful definition of data science, it is also called as KDD process, knowledge discovery database. It is a data driven science. It is an interdisciplinary field about scientific methods, processes, and systems to extract our insights from data in various forms. Either it is structured format, unstructured format. If you take data science is a KDD process, as a programmer, we are starts with quality data. How we are getting quality data? Before quality data, we are doing pre-processing, eliminating redundant data, noisy data, dirty data, inconsistent data, etc. Then data becomes data quality. Then descriptive data, diagnostics data, predictive data, and semantic data. And finally, we are getting knowledgeable data. That is called the KDD process. Data science is a combination of visualization, statistical modeling, statistical computing, data technology, data research, data consulting, real world applications, scientific methods. There are three important characteristics of data science. Data volume. What is the size of the data we are handling in the real-time environment? Data variety. How many types of files we are handling in the real-time environment? Audio, video, text, graphics, animation, etc. Data velocity. What type of databases we are handling? Batch processing, periodic data, near-time data, real-time data, legacy data, old data. What type of database we are handling in the real-time environment? Why do we want to study data science? In your mind, you are getting doubt. That's why if you are collecting more data, it leads to the more knowledge. More knowledge leads to the more money. All business magnates, they are increasing their businesses because of this more knowledge. How you got more knowledge? You are collecting more data. Then we are doing pre-processing with help of pre-processing techniques like binning, box plot, etc. Data science is the process of examining large amounts of data of variety of types to uncover hidden patterns, interested analytics, unknown correlations, and the other user information. That is called data science. So why data science? What is the responsibility of data science now? We are collecting data from various sources like cloud computing, Internet of Things, big databases. That is called datafication. Once we got the data, then we are doing pre-processing. Then we are applying the machine learning algorithm. Then we are developing a model. Then finally we are getting the results. We are analyzing the results. So why learn data science? My dear participants, my dear students, so it is a fuel for 21st century. Problem of demand and supply, a lucrative career. Data science is changing the world. Data science is a future because we are solving complex applications. So Facebook alone generating 1,000 terabytes of data daily, whereas many other organizations like Jet Airways, stock exchange market generates terabytes of data every hour. So data science is a collection of data sets which is so large and complex that is difficult to handle using DBMS tools. There are three types of data we are handling in the real-time environment: structured data, unstructured data, semi-structured data. So with help of relational databases, SQL, MySQL, Teradata, DB2, we are creating the tables and databases. This is called a structured data. Examples, tables, transactions, legacy data, etc. Unstructured data is nothing but there is no schema, there is no procedure, but we are creating a databases like a Facebook database, health database, stock market exchange database, audio, video, text, graphics, animation, YouTube videos that comes under unstructured data. So in order to process unstructured data, we are using Hadoop, Spark, MATLAB, R, Python, Advanced Java programming languages, tools. Then semi-structured data. It is a 50% structured data and 50% unstructured data. That is called a semi-structured data. So who uses data science? Big giants in the market: Disney Parks, Google, Amazon, NASA, Booking.com, Discovery, Facebook, Uber, LinkedIn. These are the very big giants are using this data science applications. What is the structure of data science? Data processing, it is consists of three tiers. Tier 1 data science, data sources, tier 2 big data analytics, and finally tier 3 analytics. Data sources consist of structured data, unstructured data. We are giving as input to the system, and we are choosing the tool and technique and the algorithms: Hadoop, Hive, MapReduce, MATLAB, Spark, R, Python, etc. Final analytics, we are generating dashboards, reports, and scorecards through pie chart, bar chart, line chart, etc. And there are various data file formats such as audio, video, image, text, graphics, animation, SQL files, DB2 files, public record, books, transaction, documents, etc. Data science is an interdisciplinary subject. We are using statistical methods like linear regression, non-linear regression, logistic regression, statistics operations like mean, mode, standard deviation operations. We are using advanced computing, cloud computing data centers we are using. Then visualization purpose, we are using R, MATLAB, Tableau, etc. Data science is a multidisciplinary subject. See how many subjects are incorporated in this one: statistics, pattern recognition, machine learning, data mining, databases, and data processing, visualization. So this is the all subjects integrated. See now data science integrated with software development, because we are using Python, Java, or MATLAB, etc. And then business analytics we are generating, and statistical mathematics we are using, like linear regression, non-linear regression, and logistic regression. Machine learning algorithms we are using, such as classification, clustering, association rule mining, outlier detection, recommender engine. In machine learning, 3 types we are using: supervised learning, unsupervised learning, reinforcement learning. Data science roadmap. If you see, the first we need to frame the problem, then unstructured data, and then you need to understand the data, then extract the features, then develop a model. That model predicts the results and code. So this is a data science institute. There are 5 steps: capturing the data with the help of data acquisition, data entry, signal reception, data extraction. Then we are maintaining the database with the help of data warehousing tools like Informatica, Hadoop, Hive, HBase, Cassandra, etc. Then data cleaning. Pre-processing is nothing but data cleaning, eliminating the redundant data, noisy data, inconsistent data, dirty data. Data staging. We are converting one form to another format. That is called data staging. Data processing, data architecture, etc. Process, we are using data mining, clustering, classification, data modeling, data summarization. Finally, we are analyzing the data, text mining, regression, predictive analytics, qualitative analysis, explorative analysis, etc. And communication. Finally, we are connecting with the end users. Then this is the life cycle of data science. Understand the problem, business, data collection, data preparation, exploratory data. Then we are developing the model, model evaluation, model deployment. These are the major components of data science. Data. There are 3 types of data I have already explained: structured data, unstructured data, semi-structured data. Data is a collection of factual information. Big data is nothing but deals with the large data sets which are traditional systems are unable to process the data. Big data is enormously big data sets, various V's: volume, velocity, variety, value, veracity, vision, validity, etc. Machine learning is nothing but learning from the observational data. There are 3 types of data we are handling in the real-time environment. Okay. Any doubts if you are getting, please ask me. Supervised learning, unsupervised learning, reinforcement learning. These are the 3 types of machine learning techniques. I am going to show you practicals. Then statistics and probability. The numerical foundation of data science is insights and likelihood. There we are applying 3 types of techniques: linear regression, non-linear regression, logistic regression. Then finally we are applying programming languages like Python, Java, or MATLAB, Julia programming, etc. Why Python is so popular? Rich number of packages we are using in this Python programming. Recently, I have used Keras, TensorFlow, PyTorch, sklearn, NumPy, Pandas, various packages I have used in order to solve the deep learning and machine learning applications. Then what is the difference between data analyst and data scientist? Data analyst is concentrating only two parts like business administration, domain specific responsibility. For example, marketing analyst, campaign management, financial analyst, equity research, etc. Data exploration analysis and insights. Data scientist is concentrating on data exploration, analysis and insights. Advanced algorithms, machine learning, deep learning algorithms is applying for various applications. Finally, data product engineering applications is going to developing. So the process of data science, final step, acquiring the data, preparation of the data, reformat and clean the data, then analyze the data and applying technique and getting the results and analyze the results. Finally, we are communicating with the customers, end users, stakeholders. These are the data science tools. SAS is nothing but statistic analysis software. We are using SPSS, Apache Spark, BigML, D3, MATLAB, Excel, Tableau, Jupyter, MATLAB, Lib, Natural Language Toolkit, Scikit-learn, TensorFlow, Keras, various tools we are using in order to solve the data science applications. If you see the Tableau for visualization purpose and Excel also we are using to generate the statistics, Rapid Miner, it is a data mining tool, Data Robot, and ClickView and H2O, TensorFlow, BigML, Snowflake, Trifacta. These are the data science tools. Usually there are five kinds of data science tools we are using. Data store purpose, we are using Mongo database, MySQL, Hadoop, like that. Then transformation, we are using Spark, Python, SQL, etc. Then for modeling purpose, we are using Panda, Spark, sklearn, etc. For visualization purpose, we are using R program, Tableau, D3, etc. Other tools like Kafka for messaging tool, RabbitMQ, various tools we are using. Then data science, if you want to settle as a data scientist in the market, you must have knowledge on mathematics and statistics, ethical skills, team player skills, lifelong learning skills, communication skills, real world, machine learning, data visualization skills, data wrangling and data wrangling is nothing but
Hello?
Data wrangling is nothing but hello?
Pre-processing the database.
Processing the database.
We are eliminating noisy data, redundant data, inconsistent data, dirty data, etc. Then skills as a data scientist.
Then skills as a data scientist have data mining.
Technology, analytics, machine learning, Python,
or etc.
Hello, sir. My voice is audible.
Sir, some echo is coming, sir. I think you have switched on to. Now it is okay, sir. Hello, sir.
Hello, sir. My voice is audible.
Yes, sir. Yes, sir. Now
my voice is audible.
Yes, sir.
Okay.
Okay. Hello, sir. Hello, sir.
Hello, sir. My voice is audible.
Yes, sir. Yes, sir. It is
Hello.
audible, but screen share has stopped, sir.
Yes. I'm giving. So 70 to 80% statistics we are using in order to solve the real-time database applications, data science applications. Then machine learning algorithms we are applying, and finally visualization 5% tools we are using like R, Tableau, various tools we are using.
Sir, screen share is not there, sir.
Yes. I'm sharing right now. One second, sir.
Okay, sir.
बीच में वो स्क्रीन नहीं आ रहा, स्क्रीन का नहीं पता। अरे आपका इंटरनेट गया। इसमें screen share. So my dear participants, any doubts if you are having, please post in the chat box so that I am going to clarify your doubts. Don't be hesitation mode. You must ask queries so that you can update knowledge in this data science domain. Here I am going to cover 5 subjects like statistics, AI techniques. Sir, please allow me, sir.
Okay, sir.
I'm going to share my screen. Please allow me.
Sir, now you can check, sir.
Yeah, it is coming now.
Okay.
So now my screen is visible.
Yes, sir. It is visible, sir.
Okay. So this is the way we are solving data science application. Statistics 70 to 80%, machine learning 10 to 15%, predictive modeling 70 to 80%, 30% text mining, visualization 5%. So my journey to become a data scientist and head research, I have applied like this step-by-step procedure. Understand the customer's business, define the metrics that matter, translate for non-technical audience, statistical packages, advanced mathematics, experimental design, model fitting, scripting languages, predictive analytics, and hacking and coding tools like SQL, MySQL, Teradata, Hive, HBase, data governance, data preparation, get the right and ask good questions, make it actionable. So 5 subjects I am applying in this data science. What are the data science advantages and disadvantages? So it's in demand right now. Abundance of positions, highly paid career, highly prestigious jobs are available, versatile. Disadvantages, it is blurry term, mastering data science is near to impossible, large amount of data knowledge is required, arbitrary data may yield unexpected results, etc. What are the applications of data science? Image recognition, speech recognition, Internet of Science, digital advertisements, recommender systems, price comparison websites, gaming, delivery logistics, fraud and risk. These are the various applications we are solving with help of machine learning and deep learning applications. So data science use cases, Amazon is the big giant in the market, improving e-commerce experience. They are using machine learning, deep learning application algorithms, optimizing rides. Uber, Bank of America, increasing customer experience, and Airbnb, improving searches. They are using machine learning and deep learning techniques. And data science use cases, I have already explained what are the major use cases in the real-time environment. Healthcare, targeted advertisement, image recognition, fraud and risk detection, price comparison websites, internet searches, speech recognition, predictive systems, online dating, product delivery. Various use cases are available right now in order to solve real-time applications. Data science use cases. The major use cases in healthcare right now in this pandemic period we are using. Recently I have collected 960 X-ray image databases from the hospitals, and then after collection of real-time X-ray images from the hospital from
Yes,
UCI website. Yes, sir.
Sir, screen share has stopped, sir.
Yeah. And after that, I have collected a few more synthetic data sets from Kaggle database, UCI database. Then I have applied machine learning and deep learning algorithms.
Hello, sir.
Sir, my screen is visible?
No, sir. Yes, sir. Now it
Sir,
is.
my screen is visible, sir?
Yes, sir. Yes, sir. Yes, sir. It is visible.
Okay. Yes, yes. And data science case studies. If you see the data science in pharmaceutical industries, predictive modeling for maintaining oil and gas supply, data science in biotechnology, data science in education, everywhere we are using machine learning, deep learning techniques. So the future of data science, algorithms especially we are using massive scale graphing algorithms, geospatial, temporal, predictive analytics, and hyper fast analytics, embedded deep learning, cognitive machine learning, natural language algorithms, and AI techniques. Applications in future of data science, cyber security applications, healthcare data analytics, IoT, Internet of Things applications, smart everything, customer engagement expertise, and data for a societal good purpose we are using. And the summary, all of them have a tech background. Machine learning and data mining are the common skills. Programming, statistics, database, and visualization are the top areas they specialize. So you must have knowledge on Hadoop stack, mathematical modeling, NLP, machine learning, behavioral economics, predictive analytics, data algorithm, Python, SQL, or Julia programming, etc. So what is the mathematics you require to solve data science applications? What type of mathematics we are using in maths, linear algebra and calculus we are using. In statistics, we are using descriptive analytics and inferential statistics we are using. Sorry, here a lot of disturbance is there through internet. Sorry for inconvenience. Again, I'm connecting my screen. So what type of mathematics we are going to use in data science applications, especially descriptive statistics, inferential statistics. I am going to show you practicals, linear regression algorithm in Python, how we are using for predictive database applications, and linear regression, nonlinear regression, logistic regression, how I am using linear algebra, calculus, etc. I am going to explain these practicals. One second. A lot of disturbances there. So now my screen is visible.
Yes, sir.
Hello, my dear friends.
Yes, sir. Yes, sir.
Yeah.
Visible.
So statistics, I think everybody knows. Statistics, there are two types of statistics we are studying, quantitative statistics and qualitative statistics. So statistics can be used to derive meaningful insights from data by performing mathematical computations on it. Okay, so statistical methods, descriptive methods and inferential methods we are using. In descriptive methods, we are using three types: univariate methods, bivariate methods, and multivariate methods. Inferential methods we are using central limit theorem, binomial theorem, and hypothesis testing, normal distribution, and applied to means like t-test, ANOVA, psi-test, chi-square test, etc. we are performing. I have explained already. Data may be a two types: qualitative data, quantitative data. In qualitative data, we are using like a categorical or attribute like marital status, political parties, eye color, etc. Quantitative data, we are discussing data that represents counts or measurements. There are two types: discrete and continuous. Number of children, defects per hour, continuous, weight and voltage, etc. So in basic probability and statistics, we are using central tendency like mean, median, mode, and outliers. Measures of spread, we are using range, standard deviation, variance, and quartiles. In percentiles, we are using position of a data, percentile, rank, percentile range. Probability distribution, we are using uniform distribution, normal distribution, that is called Gaussian distribution, Poisson distribution. Dimensionality reduction, we are using pruning techniques, especially in image processing, face recognition application, we are using principal component analysis. And sampling, we are using software, a requirement software, we are using statistics requirement software, reservoir, undersampling, oversampling. Bayesian statistics, we are using like P of A by B is equal to P of B by A into P of A by P of B. That is called Bayesian statistics, measuring belief or confidence problem we are using. Covariance and correlation, how data is related. And these are the statistics formulas we are using in data science: mean, variance, median, mode, etc. I think everybody knows. Then statistics for data science, we are generating a graphs like a sine wave, bar chart, line chart, okay, and arrow mark chart, pie chart, etc. So it is used to process complex problems in the real world, so that data scientist and analyst can look for meaningful trends and changes in data science. So it is used to derive meaningful insights from data by performing mathematical computations on it. So these are the basic statistics formulas we are using. Population measures like mean, variance, standard deviation. Sampling, we are using sample mean, sample variance, standard deviation, Z score, correlation. In linear regression, we are using formula, probability, like binomial distribution, one sample Z statistics, like confidence interval formula, margin of error formula, minimum sampling, one sample T statistic, two sample T statistics, sample proportions, two sample proportions, chi-square statistic, etc. So there are 8 basic statistics we are using, concepts, in order to become a data scientist. Understand the types of analytics: probability, central tendency, variability, relationship between variables and probability distribution, hypothesis testing, and regression. I'm going to show you types of analytics like descriptive, diagnostic, predictive, prescriptive analytics. I'm going to show you practicals. Then probability, I think everybody knows: complement, intersection, union. Then conditional probability, independent events, how we are using mutually exclusive events, Bayes theorem, just now I have explained. Central tendency, there we are calculating mean, median, mode, skewness, kurtosis. These are the things we are applying in central tendency. Variability we are using range, percentile, quartile, that is called IQR. Again, we are calculating percentiles, quartiles, interquartile range, etc. Then variance, standard deviation. These are the popular formulas, especially we are using in a population, sample, etc. Standard error, we are using population method, sample. An estimate of the standard deviation of the sampling distribution. Relationship between variables like causality, covariance, correlation. So that is called a relationship between variables. And the probability distribution, we are using three methods like PMF, PDF, CDF. Probability mass function, probability density function, cumulative density function, etc. Then a continuous probability distribution, we are using uniform distribution, normal Gaussian distribution, and Poisson distribution. Okay, exponential distribution, chi-square distribution. Why we are using chi-square distribution? The distribution of the sum of squared standard normal deviates. For that purpose, we are using chi-square distribution, discrete probability distribution, Bernoulli distribution, binomial distribution, Poisson distribution. In order to increase the prediction levels of the application. These are the formulas. And why we are doing testing? In order to eliminate the bugs in the runtime duration. Those are called exceptions. In order to solve exceptions, we are using hypothesis testing, like null hypothesis, alternative hypothesis, etc. We are using interpretation purpose, p-value, critical value, significance levels, and rejection region we are using. Z test, I think everybody knows why we are using Z test, whether it is working for one sample Z test or two proportion Z test. Okay, and T test also we are using in statistical test. If the population variance is unknown and the sample size is not large, n less than 30, then we are using T test. Okay, and ANOVA test. I think everybody knows ANOVA, analysis of variance. ANOVA is the way to find out if experiment results are significant. One way ANOVA, two way ANOVA we are using. Very interesting technique in SPSS tool. Statistical package for social science and SAS tools we are using that in order to perform ANOVA testing. Chi-square test, goodness of fit test, chi-square test for independence, etc. So chi-square test checks whether or not a model follows approximately normality. When we have a discrete set of data points, then we are using chi-square test. Okay, regression. There are three kinds of regression techniques we are using. First one is a linear regression. Linear regression is a approach to model the relationship between dependent variable and one independent variable. That is called y is equal to mx plus c. M is the slope and c is the constant. And there is a y is a dependent and x is the exploratory variable. Now see, this is the linear regression formula. Y is equal to, say, dependent variables and independent variables are a prediction. And y intercept. See, now I am going to execute this linear regression algorithm. We are using understand the model description, causality, and directionality. In step 2, we are using check the data, categorical data, missing data, and outliers. Step 3, we are using simple analysis. And step 4, multiple linear regression, check the model and the correct variables. Step 5, residual analysis. Step 6, interpretation of regression output. This is the way I am going to show you right now, practical. Simple linear regression. If you see the step by step how I have executed in Python programming, import packages and classes, provide data to work with, eventually do appropriate transformations, create a regression model and fit it with existing data, check the results of model fitting to know the whether model is satisfactory or not. So this is the algorithm. This is the Python code, linear regression Python code. Now I am going to show you practicals, linear regression, non-linear regression, and logistic regression. Please see my screen. My screen is visible, sir. Please check now, all of you.
Yes, sir.
My screen is visible.
Yes, sir.
Okay. So now I am going to execute. Python 3 in the command prompt I am executing Python 3. See, first linear regression demo I am going to execute now. If you want to see the code, see, I am going to show you. So in this Python is the command and linear regression demo is the .py. Now it is executing. It will generate graph and mean, intercept value. So what I have shown in the it is processing now. See, now it is generated. I have taken X array. This is the graph. It is generated now. Now see, all of you, this is the X value I have taken. NumPy array I have taken 5, 10, 25. See, if you see the, wait, I'm showing. My screen is visible. Hello, sir. My screen is visible.
It is visible, sir.
Yeah. Now see, I have imported NumPy. See, import NumPy is a package as a NP. And from sklearn.linear_model import linear regression, what I have taken, import matplotlib in order to generate the graph. So I am taking a without reshape is a variable. NumPy array I have taken F5, 15, 25, 35, 45, 55 print before reshaping NumPy array. Then X is equal to NP means NumPy package variable NP dot array. Reshape -1, 1 means columns becomes rows, rows becomes columns with this function. After reshaping NumPy array, then I'm printing those values, then applying the model. So in this model, I'm using a linear regression inbuilt package code available in NumPy package from sklearn. From sklearn, the linear regression model is available. I am applying that function model.fit of x comma y. Then I am calculating mean square error. Then printf coefficient of determination. Then intercept value. Then slope value. Then testing. By prediction value, I am predicting the values. Then show. This is the values I have generated. Now see once again. This is the way I am executed. Okay. Now my screen is visible, all of you. If you want to see my code, notepad. Okay. This is the code I have written. See, this is the in Python code. Okay. Same code I have written and executed. Now, if you see non-linear regression. So this is a linear regression. Again, I am executing a non-linear regression. See, non-linear.py. This is the graph I have generated. Okay. So this is the graph, and these are the values. So now if you see in this one, non-linear regression, multiple, I mean y is equal to b0 plus b1x, x1, b2x, b2x2, etc. We are calculating y-intercept values, slope coefficient, error term, etc. Non-linear regression, regression trees and random forest, which are tree-based non-linear algorithms we are using under non-linear regression. This is the code I have used, non-linear regression in Python code. Okay, these are the results I got it. I'm showing through my presentation. Again, I'm going to execute in a command prompt one more, logistic regression. Logistic regression is a statistical model that in its basic form uses a logistic function to model a binary dependent variable, although many more complex extensions exist. Okay, so this is the formula we have used in logistic. The difference between linear regression, logistic regression. Okay, and logistic regression algorithm, it derives 0 or 1 finally. This is the code I have written. This is the values I am getting. This is the graph I have generated. Now see, again I am going to execute logistic regression, Python, and this is a logistic.py. So I am going to share with you all sort of programs and code applications, everything I am going to share with you. Okay, so these are the results I have generated. Now I am moving to artificial intelligence algorithms. I am going to execute 3 more algorithms. Then data mining algorithms I am going to show you. Okay, so now see what are the top 10 statistical techniques. Linear regression, resampling methods, shrinkage, dimension reduction, classification, non-linear models, unsupervised learning, tree-based methods, support vector machine. What is the difference between data scientist, data engineer, statistician? So data scientist is using Python, SPSS, Julia, Spark, R, MATLAB, etc. Tableau. Data engineer is using MapReduce, Spark, Cloudera, Mongo database, HBase, Cassandra, SQL database, Pentaho. Then a statistician especially is using R, MATLAB, Excel, Wolfram Alpha, etc. The difference between a statistician, data scientist. Data is given in text files. Need to get data for databases. Focus on modeling, focus on results. Bring data to model, bring model to data. Further away from production system, embedded in production system. So these are the various features between a data scientist and data analyst. Background: a data scientist deals with the various data operations. Data analyst, his role is related to data cleaning, transforming, generating, etc. Scope: involved with several underlying data procedures. Involvement is limited to small data and statistic inferences. Type of data: it handles structured data, unstructured data. Data analyst deals with the structured data only. Skills: possesses knowledge of mathematics, statistics, and machine learning algorithms. Has problem solving skills, knowledge of basic statistics. Tools like proficient in SAS, Python, R, TensorFlow, Hadoop, Spark. Knows Excel, SQL, R, Tableau, etc. So this is the work each person responsibilities, like data scientist is performing on data analysis, statistics, machine learning, data mining, statistical modeling, research algorithms, analytics, programming. Data engineer works on data warehousing, ETL tool. I think everybody knows extraction, transformation, loading tool. Informatica, Hive, HBase, Cassandra, etc. Databases, business intelligence, and data scientist uses MATLAB, SAS, software analysis, statistics. Data engineers use Oracle, Hadoop, Microsoft SQL Server, MySQL, Hive. languages like R, Python, LaTeX, C++, data engineers, Java, Linux, etc. Data analyst versus data scientist, less pay, less experience. Data scientist, more pay, more experience. And statistic modeling, predictive modeling, basic programming, advanced programming we are using in MATLAB. You know, Keras, TensorFlow, sklearn, PyTorch. These are the various frameworks I have used for prediction detection of health database applications. Recently, 6 database applications I have executed. So then support vector machine. I'm going to explain this SVM and principal component analysis and decision tree algorithms in data mining. So okay, now the second concept is artificial intelligence. Intelligence behavior in a machine is called artificial intelligence. The science and engineering to make intelligent machines. It is proposed by John McCarthy in the year 1969. Intelligence is nothing but the ability to reason, the ability to solve novel problems, the ability to act rationally and efficiently, the ability to act like a humans. Okay, in artificial intelligence, mimic like human, okay, think like humans. So intelligence is demonstrated by machines, unlike the natural intelligence displayed by humans and animals, which involves consciousness and emotionality. See, AI is a popular branch of computer science that concerns with building intelligent smart machines capable of performing intelligent tasks. With rapid advancements in deep learning and machine learning, the tech industry is transforming radically. So this is a difference between deep learning, machine learning, artificial intelligence. Technique to perform machine learning inspired by a human brain's network of reasons. That's why deep learning is a sub-branch of machine learning. Machine learning is nothing but learning from the observational data, and with help of supervised learning, unsupervised learning, and reinforcement learning. Artificial intelligence means so imitating the intelligence or behavioral patterns of humans or other living entities. So where AI is used, predictive analytics, real-time operations management, customer services, risk management and analytics, customer insights, pricing and promotion, customer experience, supply chain, human resources, fraud detection, knowledge creation, research and development, etc. The 5 most important concepts of AI: machine learning. Learning from the observational data is called machine learning. Learning from the actionable data with a deep manner, we are using deep learning. We are using neural networks like artificial neural networks, convolutional neural networks, deep convolutional neural network, recurrent neural networks, collaborative filtering. Especially we are using commercial websites like Amazon, Flipkart, etc. There we are using recommender engine. Then finally predictive intelligence. Artificial intelligence playing a vital role in this data science. We are applying top 10 data science algorithms in this data science. So what are the features of AI? We are using deep learning, facial recognition, automatas, data ingestion, cloud computing, quantum computing, chatbots, etc. Okay, so data mining deals with the raw data collection, data processing, data cleansing, exploratory data analysis, novel modeling algorithms, communicate, visualize, report. If you see the green rectangle box, we are applying model and algorithms and neural networks, data production, intelligent agents. If you see the yellow box, it includes machine learning. If you see the only blue rectangle box, neural networks, data production, intelligence agents, that is called deep learning. So these are the AI and ML components, like development tools. We are using R, Python, Jupyter, etc. Languages like C Sharp, R, Python, Julia, Java, etc. Data platforms, we are using Spark, Hadoop, SQL Server, PostgreSQL, etc. Machine learning AI tools like H2O.ai and DMLC, XGBoost, and data exploration visualization tools, Excel, SQL Server, Weka. Weka is a data mining tool, Waikato Environment Knowledge for Analysis. Two faculty members invented Weka tool from Waikato University. It is located at New Zealand. And the data ingestion tools like SQL Server. Okay. And disconnect. So again, one second. So these are the AI ML components. So what are the pros and cons of artificial intelligence? Increased efficiency in artificial intelligence, reducing human risk, aid in decision making, availability. And disadvantages like cause of unemployment, high initial investment, dependency on machines, lack of creativity, etc. These are the top 10 most popular AI models: linear regression, logistic regression, linear discriminant analysis, decision tree, naive Bayes, k nearest neighbor, linear vector quantization, support vector machine. I am going to execute SVM and decision tree and few more algorithms, bagging and boosting, deep learning, etc. So these are the factors, differences between data science and artificial intelligence. Scope, types of data, tools, applications, especially applications we are using advertisement in data science, marketing, internet search engines, etc. And manufacturing, automation, robotics, transport, healthcare, etc. Scope, it involves various underlying data operations in data science, limited to the implementation of machine learning algorithms. Types of data, structured data, unstructured data can handle in data science. Standardized in the form of embedding and vectors. Tools, data science, R, Python, SAS, SPSS, TensorFlow, Keras, scikit-learn, etc. In artificial intelligence, we are using scikit-learn, Caffe, PyTorch, TensorFlow, Shogun, Mahout, etc. Next, the third subject is data mining. Data mining is the process of extracting meaningful interested patterns from the large amount of data. So there are 4 stages: data sources, data exploration, data modeling, model deployment. See, next is the mother of invention, Han and Camber. If you read it, data mining and data warehousing textbook, 2 authors, they have done 10 years research on frequent pattern mining concept. They invented very surprising items. 10 years legacy data they have collected in the US Walmarts, and they kept in the data warehouse. Then they applied the prediction algorithms on the database. Surprisingly, they got 2 interested items. Usually, US employees, they are outing every Saturday and Sunday with families. So this Han and Camber done very good research on that 10 years database of supermarket and Walmart's data sets. They have taken as input and applied prediction algorithm. Surprisingly, they got 2 items. Those are the diaper and beer. So these 2 items are heavily sold out in their markets. So they have done very good research in this. Okay, so in this Nesty is the mother of invention. They have given this dialogue. Okay, and surprisingly, they got 2 items heavily sold out. Those are the diaper and beer, because all employees of USA, they are outing every Saturday and Sunday. So 10 years data they have collected. They have applied prediction algorithms. Surprisingly, they got 2 items are heavily sold out. Those are the diaper and beer. So that's why we can call it as a hidden patterns we are extracting from the huge volume of data. What is the difference between data science and data mining? So data mining is a sub branch of data science. You can call it as qualitative analysis, multidisciplinary, unstructured data, data products. In data mining, we are using extracting data, discovering hidden patterns, developing predictive models, etc. Then these are the top 10 algorithms we are using. C 4.5, that means classification 4.5, naive-based classification, CART. What is a CART expansion? Class and classification and regression tree. PageRank algorithm, support vector machine, ADA boost, array algorithm, FP growth, especially in frequent pattern mining, K-means algorithm, etc. These are the top 10 data mining algorithms and data mining softwares. Veka, Rapid Miner, Nine, Mahout, Rattle, R Programming, Orange, NLTK, Natural Language Toolkit, Scikit-learn, sklearn, MATLAB, LBSVM, data mining like CART, Naibase, KNN, ADA boost, PageRank, expectation and maximization, a priori, support vector machines, K-means, C 4.5 classification algorithms, etc. This is the comparison between data collection, data mining, data compression, experimentation. If you see the process parameters, so microstructure, properties, performance in data collection, data mining, process modeling, microscale simulation, multi-scale analysis, performance prediction, data communication, reduced order modeling, stochastics, pattern recognition, PCA, principal component analysis, uncertainty. So these are the data analyst skills like data visualization, data cleansing, MATLAB, R, Python, SQL, NoSQL, machine learning, linear algebra and calculus, strong Microsoft Excel skills, critical thinking, communication, etc. And this is data mining, data science analytics. I have explained already all the terms, jargon. My dear participants, please post your queries in the chat box. At last 15 minutes, I am going to clarify your doubts. So in data mining is the process of extracting meaningful, interested analytics. These are the terms we are using: data warehousing, data engineering, data profiling, data translation, data mining, data discovery, text mining, machine learning, computer science, etc. Data science, science or scientist, information science, statistics, analytics, advanced analytics, etc. In analytics, machine translation, speech recognition, robotics, search engines, etc. So the fourth subject is machine learning. Learning from the observational data is called machine learning. Machine learning is a sub-branch of artificial intelligence. So it provides smart alternatives to analyze vast volumes of data. By developing fast and efficient algorithms and data-driven models, real-time processing of data, we are using machine learning algorithms. So ordinary system, how introduction to machine learning? Ordinary system with the desktop system, with AI, we are using some algorithms. Machine learning, we are applying supervised, unsupervised reinforcement algorithms in order to develop a model. That model will predict the results and it improves the accuracy. Then machine learning, there are three types. I have already explained. Supervised learning. So supervised learning class, we are categorizing the data. That is mean task driven system. And unsupervised learning, in unsupervised learning we are using a data driven system. So in this unsupervised learning we are using K-means clustering, some clustering algorithms we are using in this unsupervised learning. In classification, supervised learning, we are using decision tree, support vector machine, and decision tree, neural networks, etc. And reinforcement learning, based on the punishment and reward, we are solving the various gaming application. Especially nowadays, our students are playing PUBG, Free Fire, chess games, various games they are playing. Because of reinforcement learning, punishment and reward concepts, recovering from the mistakes, error handling in
Screen is not visible, sir.
reinforcement learning algorithm.
Sir, screen is
We are
not.
solving various applications. Yes, sir. Yes, sir. 1 second. I am reconnecting again.
Okay, sir.
So, my dear participants, if you are having any queries, please feel free to interact with me. Post your queries, any doubt related to statistics, artificial intelligence, machine learning, deep learning, data mining. Please ask me any doubt with practicals, especially in advanced Java programming and Python programming. Any library, any framework, you can ask me. I'm going to clarify your doubts. Okay. Sir, please allow me in order to share my
Sir,
screen.
already
Please,
allowed,
sir.
sir.
Sir,
Sir, already
host
it is
is
allowed,
muted.
sir.
Please. It is saying host disabled participants screen sharing. For me, you allow me.
1 minute, sir.
I have joined with Dr.Asadi Srinivasulu. One more email ID, sir.
Yes, sir. Yes, sir.
Host disabled is showing, sir.
1 minute, sir.
Hello,
check
sir.
out.
Please. No, it is not coming, sir. Host disabled.
No, sir. It is already enabled only from my side. Sir, can you re-log in again, sir? With that.
Yeah. Please allow me, sir. Now I'm sorry for this.
I think it's disconnected, sir.
Hello, sir. My voice is audible.
Hello, sir.
Yes, sir. Your voice is audible and
My-
your screen also is visible.
Please, the three types of machine learning algorithm we are using. So supervised learning, based on the label, we are classifying the data. Unsupervised learning, there is no label. Based on the similarity behavior, we are classifying the data. Based on Euclidean distance, Manhattan distance, Minkowski distance, we are using unsupervised learning with help of k-means algorithm, k-means clustering algorithm, etc. Reinforcement learning is nothing but based on the punishment and reward we are solving. That is called learning from errors. Works on interacting with the environment, whereas the supervised learning methods works on given sample data experimentation. Then types of machine learning, just now I have explained: supervised learning, task driven; unsupervised learning, data driven; reinforcement learning from errors, learning from the errors. So if you see the big data sets, we are learning and training the model. Big data models we are using, and inferencing, we are asking the query, it has to give the answer. And if it is not giving, then again we are training the model and expecting the very good results. This is the machine learning life cycle: data gathering, data preparation, data wrangling. I think everybody knows data wrangling is nothing but pre-processing the data, eliminating the noisy data, redundant data, inconsistent data, dirty data. Then we are applying the data analysis. Then we are developing a model training, model testing, eliminate the exceptions in the runtime duration. Then deployment, etc. Then how does this machine learning works? Input, we are giving input, three kinds of data: structured data, unstructured data, semi-structured data to the system, analyze data, find patterns, prediction, store the feedback. Then machine learning example, self-driving cars. These days we are using self-driving cars, especially Google started this R&D, research and development. Okay, and predicting an illness, credit worthiness, ranking on social media, computer vision, agriculture, targeted emails, and quality and assurance based platforms, fashion industry, etc. I am going to explain how reinforcement learning algorithm it works. Please check now, all of you. Left side fire is there, right side. Please analyze this scenario. My dear students, my dear faculty members, please analyze this scenario. You come to know how reinforcement learning is working. So one side fire is there and another side bucket is there. My chatbot or robo is observing two sides. So wrongly it stepped into fire. So ouch, that means there is a fire, it is a hot. So I'm deducting 50 points in that one. Then again that chatbot or robo analyzing, oh, there is a fire and there is a right side bucket with full of water. Next time is taking a full of bucket of water and pouring into the fire. That means if it does a bad step, we are giving punishment to the robot. That is called a punishing. And if it does right step, we are giving the reward. That's why reinforcement learning is called a punishment and reward concept. My dear friends, learning from the errors, learning from the mistakes is called a reinforcement learning. Understood, all of you? Types of machine learning we are discussing. Supervised learning, what are the techniques? Classification, regression. In classification, we are using fraud detection, email spam detection, especially in Gmail. Diagnostic, image classification, regression, logistic regression, linear regression, and non-linear regression, and risk assessment, score prediction, etc. In unsupervised learning, dimensionality reduction, text mining, face recognition, big data visualization, image recognition, etc. In clustering, we are using biology, city planning, targeted marketing. Reinforcement learning, especially gaming applications, we are developing with help of reinforcement learning. My dear students, concentrate on reinforcement learning, because you are playing so many games these days. In pandemic period, you are playing so many games. Playing game is not important. How to develop a game is important. As an engineering students, you must learn reinforcement learning. If you are having any doubts, please ask me how to develop a game, how to develop a chatbot application, etc. Okay, we are using in reinforcement learning, gaming, finance sector, manufacturing, inventory management, robot navigation, etc. These are the various algorithms we are using. Regression, nonlinear, polynomial, decision tree, random forest, classification, KNN, trees, logistic regression, naive Bayes, SVM, clustering, SVD, PCA, K-means, okay, a priori, FP growth, various algorithms we are using. I have explained in unsupervised learning, recommender engine, targeted marketing, customer segmentation, etc. In reinforcement learning, we are using real-time decision, game, artificial intelligence, skill acquisition, learning task, robot navigation, etc. In supervised learning, again two types, classification, regression. In regression, I am using a popular population growth prediction, estimating life expectancy, market forecasting, and weather forecasting, advertisement, popularity prediction, classification, identify fraud detection, diagnostic, etc. So these are the machine learning tools we are using. Statistical platforms, pandas, exploratory data analysis, predictive model markup language, machine learning model builders, portable formats for analytics, Mongo database, especially unstructured data, scriptable databases, Hadoop MapReduce for programming on Java, Spark, especially in Scala, Python, or Java, it supports. Storm, real-time analytics, FPGA, and ASICs we are using, GPUs and processor we are using. In machine learning softwares, we are using Weka, Apache Spark, RapidMiner, H2O, Shogun 9, and Apache Mahout, PyTorch, TensorFlow, Keras. We are using advantages and disadvantages. Easily identify trends and patterns in machine learning. No human intervention is needed in machine learning. Continuous improvement in machine learning. Wide applications we are using, handling multidimensional and multivariety data. Disadvantages: high error rate and susceptibility, data acquisition, time and resources, interpretation of results, etc. Applications of machine learning, especially check, my dear friends, we are using image and speech recognition application, medical diagnosis, statistical arbitrage, learning associations, classification, prediction, extraction, regression, various applications we are solving under machine learning. These are the applications of machine learning, like automatic language translation, medical diagnosis, stock market trading, online fraud detection, virtual personal assistance, email spamming and malware filtering, self-driving cars, product recommendation, traffic prediction, speech recognition, image recognition, automatic language translation, etc. These are the formulas I am using, main formulas for machine learning, especially naive Bayes, K nearest neighbor, perceptron, neural networks, back propagation, guidelines, and linear regression, principal component analysis, logistic regression, etc. See, now I am going to show you practicals on, okay. I am going to show you practicals, decision, SVM. Sir, my screen is visible? Sir, especially my screen is visible? Hello, sir. My screen is visible. Please.
Yes, sir. Yes, sir.
So I'm going to explain. Now I'm going to explain support vector machine, SVM. Okay. And see. So this is a Python, a support vector machine algorithm. It is going to show you analysis kernel of RBF and kernel of RBM. And so again, it is going to show you so these are the kernel.py, linear.py solver. These are the, we have developed already in this sklearn algorithm. And these are the support vector machine algorithm. Decision tree. Now I'm going to execute decision tree. Okay. Now I'm going to execute decision tree. So decision tree algorithm, now I am executing. Please observe, all of you. Decision tree.py. My file name is decision tree.python. Decision tree. So here I am calculating Gini index, gain ratio, and how the node is deciding the value, and I'm generating confusion matrix, and I'm generating the age, Fern, and the 714 rows and 3 columns I have taken. I'm calculating gain, impurity, and especially. So this is about decision tree algorithm execution. I am going to share with you these algorithms. I have executed nearly 15 algorithms. I have executed those practical algorithms and code. I am going to share with the coordinator, and coordinator are going to share with you. My dear friends, see now, deep learning, next concept, the last concept is deep learning. What is meant by deep learning? Learning from the actionable data with the deep observation. N number of hidden layers and input layers we are using. Deep learning gets named from the fact that it involves going deep into several layers of a network, which also includes hidden layers. It is a sub branch of machine learning. Machine learning is a sub branch of artificial intelligence. Okay, I think everybody knows what is deep learning. Learning from the observational data, learning from the actionable data with a deep manner. And see example, what is deep learning here? I'm giving input to the system car. It has to identify car or not. So I'm doing feature extraction, means what is the type of the model of the car color, price, various features, right side driving, left side driving. What are the special features in this car? First, I'm extracting the features. Based on that features, I'm doing the classification algorithm. Finally, it will detect whether it is car or not. So deep learning is a subset of machine learning. Machine learning is a subset of AI. AI is nothing but learning from the action, learning from the, intelligent behavior in a machine. That is called AI. In the year 1950s, artificial intelligence came. John McCarthy invented the term AI in the year 1969. Then machine learning, ability to learn without being explicitly programmed. That is called machine learning, learning from the observational data. Ability, then deep learning in the year 1990s up to 2006, still it is leading. In deep learning 2010 until date, learning from the actionable data with the deep manner, learning based on deep neural networks. Who invented deep learning? Alexei Ivankenho is a Russia faculty member. He created small functional neural networks, which is considered to the first serious deep learning learning breakthrough. So deep learning is an AI function that mimics the working of the human brain in processing data for use in detecting objects, recognizing speech, translating languages, and making decisions. That's why using multi-layered networks for machine learning, we are using DNN, deep neural networks, convolutional neural networks, recurrent neural networks. In machine learning, learning from the observational data, training machines to get better at a task without explicit programming. Artificial intelligence enabling machines to think like humans. And why deep learning? Deep learning requires larger training data sets. Amount of data I am taking x-axis and performance. Wherever huge volume of data is there, please apply deep learning techniques. Then only it gives very good accuracy. Okay. So this is the reinforcement learning concept I have already explained. How it is that chart is learning from the mistakes. So reinforcement learning is nothing but learning from the errors, learning from the mistakes. Okay. This example I have already explained. So deep learning modeling like data and labels and reference models, create, update models, train, test models, evaluate models, serve model, etc. So deep learning pipeline, data streaming purpose, we are using various data tools like HDFS, Cassandra, etc. Even pig programming also we are using under data streaming programming language. YouTube, audio, video, text, graphics, unstructured data, it can handle very easily pig programming language. It is a data flow language. Then users, data preparation analytics, we are using Jupyter, Apache, Zeppelin, Spark we are using. For especially frameworks and clustering, we are using PyTorch. TensorFlow, sklearn, and Keras. These are the deep learning and the frameworks we are using. Models for building machine learning models, very deep learning, high number of hidden layers and input layers we are using. Model serving, we are using predicted models. Then these are the tools we are using in this programming, machine learning programming language, especially nowadays popular Python and R. Python is so popular because of rich number of libraries are presented. Machine learning tools like Veka, sklearn, TensorFlow, etc. Deep learning tools, especially Keras, PyTorch. Analytical tools like Spark and Hadoop. Visualization tools are Matplotlib, Seaborn, Jupyter, etc. And what is the difference between machine learning and deep learning? See, human intervention is presented in machine learning. There is no human intervention in deep learning. My dear participants, faculty members, please observe this diagram. It gives more knowledge, more inference you can extract from this image. See the difference between machine learning and deep learning. Input I am giving same, but final output also I am getting same, whether it is car or not. But where human intervention is presented, machine learning. There is no human intervention is presented in the deep learning. Feature extraction, then classification, final output. Here, no, see here I am using hidden neurons. Feature n number of, there is no restriction. You can use n number of layers and input layers. This is the difference between deep learning and machine learning. Data, if you take data is a data parameter, needs big data set for deep learning, performs well with a small data to medium data set. Hardware requirements, it requires with the GPU in deep learning. Graphical processing units, machine learning, you can use CPU, desktop, laptop, etc. Very big application, go for high computing servers. Then engineering peculiarities needs to understand the basic functionality of the data, understands the features and how they represent the data. Training data, it takes long time in deep learning, and machine learning, it takes short time. Processing time, a few weeks, a few seconds or hours. Of algorithms, few difficult. Some machine learning algorithms are easy to interpret. So this is deep learning process. I'm taking input layers, hidden layers, L2, L3, L4. So many hidden layers we are using in order to increase the performance levels. Deep learning process I'm using in the year 1986 came actually. John McCarthy and Ivankomenko introduced a deep learning concept. Then it identifies pixel values, identify edges, identify combination in order to find out a face recognition application, identify features, then finally we are getting the output. These are the popular algorithms: DNN, CNN, RNN. DNN stands for Deep Neural Networks, providing lift for classification and forecasting models. Then CNN, especially for image classification, we are using CNN, feature extraction and classification of images. And RNN, recurrent neural networks, for sequence of events, language models, time series, etc. we are using RNN. Deep learning models, we are classifying supervised and unsupervised models. CNN, classic neural networks, recurrent neural networks. Unsupervised, self-organizing maps, Boltzmann machines, autoencoders especially we are using. So DNN, CNN, RNN can perform all these tasks like prediction, time series analytics, and video analytics, audio analytics, and traffic data analytics, stock market data analytics, Bombay stock market analytics, Sensex data analytics, weather forecasting data analytics, computer recognition applications, classification. We are using these three techniques. Deep learning methods classified into 4 types. In CNN, we are using VGG model. I have used VGG model and ResNet, GoogleNet. I have used for my research work. And RBM based methods, we are using deep belief networks, deep Boltzmann machines, deep energy models. Autoencoder based methods, we are using sparse encoder, denoise etc. These are the formulas, etc. These are the top 10 algorithms I have used for my research. Myself and my friend Tarkeshwar Barua, we have executed 6 database applications in order to predict and detection of coronavirus chest image data sets. Corona strain chest image data sets we have taken. 960 images we have collected from the various hospitals, and we have applied a TensorFlow and Microsoft Cognico Toolkit, Cafe. If you are perfect in Java programming, go for deep learning 4J, Chainer method, Keras. These are the various open source tools. Okay, and Python is integrated with so many frameworks. If you see this diagram, it is integrated with Keras, SparkFlow, TensorFlow, Theano, Torch, Lua, PyTorch, Fast.ai, and C#, Paddle, and dlib, C++. See, MaxNet is connected to Perl, Java, R, Julia, Clojure, and various tools are integrated with Python. Python is so popular because of rich number of libraries are incorporated. Thanks to Rossum, he invented the Python programming language. And what are the major applications of Python? I mean, deep learning, especially instant visual translation applications, predicting the future, chatbot, medical, self-driving cars, read lip movements, deep learning, and photo description, colorizing the images, medical care, predicting the future, advertising. So many applications are there. 5 application areas are presented: fraud and risk detection, image speech recognition, healthcare analytics, augmented reality, airline route planning. These are the top 10 fascinating applications of deep learning. Self-driving cars, especially deep dreaming, automatic mission translation, news aggregation, sound addition to silent films, demographic prediction, pixel restoration, automatic handwritten generation, detection of growth delays in children. These are the top 10 fascinating applications of deep learning. My dear friends, keep in mind and ask doubts at the last. Okay. And these are the data science application, especially e-commerce like Amazon, Flipkart. These are the e-commerce websites are getting so much benefit with help of deep learning algorithms. E-commerce, manufacturing, banking, healthcare, transport, finance, etc. These are the real-time applications. What sells most? Ice creams. Learning to speak, recognizing defects, using suggestions to make better decisions. Various fields, wherever data is presented, wherever data complexity is there, we are applying deep learning algorithms. So data science is a combination of all sort of things. You require IDE, you can use PyCharm, Jupyter, Collaboratories, Spider, RStudio, etc. Web scraping, we can use Beautiful Soup, Scrapy, URL deploy, AWS cloud. We are using Amazon. Amazon is so popular under infrastructure as a service cloud. Jeff Bezos is the CEO of Amazon company. There are 2 big giants clouds, EC2 and S3 under Amazon Web Services. Then we are using mathematics, statistics, linear algebra, differential calculus, data analysis, and machine learning, programming language like Python, R, Java, etc. So these are the tools I have explained many times: deployment tools, data ingestion tools, languages, data platforms, deep learning, virtual machines, ML and AI tools, etc. So Python, R, SQL, SAS. SAS is nothing but software analysis software. I mean, statistical analysis software, SAS, very popular. SAS tool. SPSS, for in order to generate the statistics, we are using SPSS, Excel, AWS, Power BI, Spark ML, Perl, Bash. various tools sentiment analysis. Biden won the elections. My dear friends, can anybody knows how Joe Biden won the elections? Behind, there are data scientists, 5 to especially they sit together, e-voting system, SMS, messages, every channel they have utilized and collected the database and stored in the system, and they algorithms, it's are Joe Biden lagging in that state, free of current, rice, everything, all the amenities, facilities he has been provided to the all the public where he is lagging. So definitely those states he is getting some votes. That's why Joe Biden won. Behind data analytics played by the vital role, has done tremendous work in order to win the US sector. So that's why that much importance is there for deep learning, data mining, predictive mining, sentimental mining, behavioral mining. You can do fantastic applications. How we can capture and deliver, etc. These are the challenges of data science. According to the Gartner survey, he is going to reveal every week, every month. Hardware is the number one in the market. So dirty data, he found that it is a major challenge in data science especially. Okay. And these are the skills you required, especially IT skills, business skills, analytical skills, data science. I have explained already. According to Gartner survey, he has been given beautiful data flow diagram in order to solve the real-time applications. We are following Gartner survey. So as a beginner, my dear students and faculty members, you may get doubt which is better to start, AI, ML and DL. You may get the doubt. For that doubt, I am giving the answer. If you are a beginner, just use artificial intelligence, any technique which enables computers to mimic human behavior. So better to start as a beginner artificial intelligence, learn the expert system, fuzzy logic, soft computing techniques, etc. Then you learn machine learning. It is a subset of AI techniques which use a statistical method to enable machines to improve the experience. Then you go for deep learning, subset of machine learning which make the computation of multi-layer neural networks feasible, etc. So these are the 6 database applications myself and my friend Tarkeshwar Barwa in data science research laboratory we have executed tremendous applications. COVID-19 virus detection application we have executed. COVID-19, CO stands for corona, Y stands for virus. I think, my dear students, virus, can anybody expand virus? Vital information resource under seas. That is called virus. There are many viruses are coming these days. D for disease. So it came from SARS convolutional covariance 2. I mean, COVID virus, severe acute respiratory syndrome. These are the symptoms we have extracted from the various databases, fever, cough, chills, etc. These are the X-ray images I have collected, and I have applied deep learning algorithms like recurrent neural networks, convolutional neural networks. These are the steps I have followed. Like a convolution operation, it refers to the combination of 2 functions to produce a third function. Then ReLU, rectified linear function, in order to improve the performance I have used. Pooling function, where I'm integrating, there are 2 types of max pooling and minimum pooling. Then flattening, full connection, these are the algorithms CNN I have used. Then this is the example I have taken of pneumonia, normal COVID-19 image as an input system. I have applied CNN and ResNet frameworks I have used, and 10 by 10 by 2048 image pixels I have extracted. Then concatenated those features. Then I'm applying a flattered features. Then I'm dropout function. In order to increase the performance, I'm using dropout function in convolutional neural networks and recurrent neural networks. This is the final output I'm getting. Normal image, COVID-19 pneumonia. This is the training data set I have taken. And this is algorithm I have applied in Python algorithm. Then this is the code I'm going to share with you. My dear friends, I'm going to share with you this code. I have I'm using Keras library, and that is a very fantastic deep learning framework especially in Python. And then sequential function I'm using, dropout, activation function, flatten, dense, then training augmentation configuration, then testing augmentation, then training augmentation, generates batches of augmented image data. This is the corona test data set. Then this is the chest X-ray of COVID-19 virus and severity levels of the image. This is the results. I got it 86.7. Then this is the execution flow. This is the data loss versus accuracy, execution time between COVID-19 virus, data set versus number of processors. I have used 4 processors. See my system, it stuck one time. This is the execution flow while running my application deep learning. My system got dead slow by the time while executing. Then COVID-19 data size versus accuracy. This is COVID-19 strain. So this is one more database application I have executed, same as COVID-19, but a few symptoms are differ, like sore throat and conjunctivitis, a rash on the skin, and diarrhea, discolorization of fingers or toes, headache, etc. And this is the strain input data set to the CNN model. This is a state training. This is the code RNN. I have used RNN, especially training parameters, network parameters, graph input, define weights. These are the functions I have applied in this. Finally, I got the X-ray images, X-ray, COVID-19 strain, virus, and severity levels. Then prostate cancer, I have executed one more database application. These are the symptoms of prostate cancer. I have collected various X-ray images from the Kaggle, UCI, Google database, Microsoft database. I have collected the various X-ray images. This is the training data set, and this is a testing data set. I have tested with external image. It gives the prostate cancer versus normal image. Then breast cancer, same as I have collected breast X-ray images. These are the symptoms of breast. These are the X-ray images I have taken, and this is a training data set. This is the final output. I got X-ray of breast cancer versus normal image. Then lung cancer, I have collected again 960 X-ray chest images. These are the symptoms, and these are the X-ray images I have collected, and I have applied CNN model and a training data set, and finally I got the output X-ray of lung cancer and normal image. And the last database application is Ebola virus prediction detection. Here also I have used CNN and RNN model. These are the symptoms, and 90% of infected people die if once Ebola virus attack. And these are the symptoms like headache and vomiting, abdominal pain, diarrhea, muscle pain, etc. These are the training data set. This is the code I have used, training parameters, network parameters, and define weights. This is the code I have executed. Final output, I got it. So this is the conclusion of my today's international webinar on machine learning, data science application. I have executed 960 images. We have found 149 images are positive, 234 phenomena, pneumonia positive, 250 normal and diagnostic. We got fantastic results, 89.62 and 91.54 for sensitivity for COVID-19 classes. Thank you, sir, for giving me this opportunity. These are my webinars. On future, I'm going to conduct a few more countries webinars. This is at Thailand, and this is at Malaysia. This is at Singapore, And this is as a keynote speaker at Geetam. And this is a resource person at MITS Madanapalli. And this is resource person at Sri Vidyaniketan Engineering College. This is jury member at Madanapalli MITS. And this is keynote speaker. And this is doctorate from JNTU Anantapur, Bharat Vidya Ratan Award from Delhi in the year 2018. And this is best IT teacher of the award, ITAP best IT teacher award at Hyderabad 2020. And this is best local chapter award from IIT Madras in the 2019. This is international seminar at Salem. This is Sangam University at Rajasthan. I have given the talk. This is ABS College at Ghaziabad. This is at Jaya Engineering College, Tamil Nadu. And this is a webinar on Maharshi Markandeya Engineering College, Punjab. And data science talks at Blue Crest University. This is big data analytics using Spark at Oman, Saudi Arabia, I have given. And this is a data science application hands-on. And this is at Russia. I have delivered a talk, COVID-19 strain virus detection. And this is 2 days big data symposium at Blue Crest University. This is from Russia. I got the Young Scientist Award from that Russia University. And this is 2 days a symposium on data science application. This is at Bharatiya University, Tamil Nadu. And this is Lord's Institute of Technology, Hyderabad, IT career and opportunities. This is data science using R programming. And this is at Reva University, Bangalore. I have acted as an international panel member and I delivered a talk. This is Karpaga Vinayaka College of Engineering at Tamil Nadu. And this is at Vijnana Bharati, Hyderabad. Topic is implementation of data science application using machine learning algorithms. This is a research conclave I have conducted, and I have invited 49 universities, and we have conducted research conclave. This is at Krishna University, data science application using machine learning, deep learning techniques. And this is at KL University. I have conducted 2 days on robotic process automation tools, UiPath and Blue Prism. These are the popular tools under automation, robotic process automation. I have given 2 days with practical sessions. Then